Hello friends, so in the last video we have seen how to create a linked list in a very basic form as seen here. So in here what we have is we have two nodes N1 and N2. So both of the nodes we are allocating memory and we are pointing N1 to N1 to N2. N1 dot next is equal to this N2 here. So like I have, if I draw it visually, so this block is N1 and this block is N2 and both are connected. And this N2, as I've seen here, it's null. So it's pointing to null here. This N1 have two value, this three, and this way it's connected. So if I need to add one more node here, so what I have to do, I have to put, mm, so what I have to do is I have to add one more node here. Maybe the value is 4 and this is N3 and it will point to null then. Okay. So in here, if you see, we have one more node N3 here. Okay. Our N3 and here we have N3. This N2 points to next gives N3. Okay. So this way we keep on incrementing. But if you see here, there are multiple lines that is created for malloc. Okay. So if we have 17 nodes or 18 nodes or 50 nodes, we cannot do this way. Okay. So we need to create one function that will do or create this node. So in this video, we'll start with that function. We'll name it as create node. Okay. So I'll make a create node function that will be called for creating a node. So when we're calling, we'll take create node, then we should have the value of the node that will be passed here. Okay, so this is calling. So let's start. Okay, so let's delete these all. So we know it only one function. So I will take create node function. Okay, so what I will do is I will put a value same like to create node 3 here and so on. Okay, so what will be the function parameters? So I have a struct node star here. Then I have create node as the API name. Then I have int value. Okay, then I start and last what I have to do, return that node last one. Okay. So inside this, what I have to do is I have to give the memory to the node. Okay. So I have struct node star new node. I'll take the name. Okay. And equal to, then I have struct node star. Then I have malloc of this, and I will go for size of node I can take. This way, we allocate memory to the node. So if new node is equal to null, if the memory is not been allocated, then what to do? Then we have to print memory allocation failed, and we can exit as well. So I'll exit from here if malloc failed. So the memory of the node is not created. Okay, so next part is giving this next pointer. Okay, so what I will do, I will take new node points to node value. It should be this value which is passed from this function. So I'll take it here value. and next pointer. Then this node next pointer will be null and return this new node. Okay. So what it will do, it will create a node and give the new node address to these APIs. Okay. So this way it's fine. Okay. We allocate the memory and give all the things over here. So we have an empty node, right? So these will create two independent nodes and no one is linked right now. So in order to link this node to each other, what we need to do, we need to have a main pointer. That is an entry point of this linked list. Okay. So in linked list, what is the difference between a linked list and arrays? Array can directly jump to that index. We have a hash map over there. But in case of linked list, we have to traverse to each node till we reach to that index. So for example, we need to get the fifth, memory slot of this structure. We have to traverse to 1 to 5. Okay. So here, what I have to do, I will take a root structure. So struct, sorry, node start head is there, or root or head. I can take like this. So head will is self-explanatory. So it's the head of the linked list. Okay. So if we give this create node like this, then what happened? I'll give to the head. So when the first node is created, this memory, this create node memory is allocated to this head. Okay. And next, what we do is head points to next is equal to this create node. Okay. So the second node will be head point to next. So head will be approaching. So the third will be head points next to next is equal to create node. Let's take the third node as 4. So every node is ending with null. Okay. So the last node will be pointing to null only. So this head is pointing to this node. Head as this head have this memory. So head point to next is this first node next. So that is the address of the next node. So this way we will be creating this linked list one by one. And for traversing, what I have to do, I'll take while loop over here, take head not equal to null. Okay. And next is we have to traverse to each and every node. Okay. So what I have to do is I have to take head is equal to head points to next. Okay. And here I will printf percentage d. I'll do like this. Okay. And comma, and we have head points to what do you say? This node value. So if head is not equal to null, it goes on increment till this head pointer become null. That is the last node. This node. This node is pointing to next because this value is not updated after this. So let's try once. So you see here, first is the second node, third and fourth. So if I print head value, so head is equal to percentage d. I'll print at the last. Okay, and here I have head. So you see here, head is pointing to the first node itself. So this value head points to node value should be the value 2. It should be the value 2. Let's see if the value is 2 or not. No, it's giving you some null value. Okay, why this happens? Because this is the main head pointer. We should not move this head pointer. So this head pointer is already been changed and it goes to the last of the linked list. That is this after this head point to next when it is null. So that's why it's giving us some null value. So how to resolve this error? So what I have to do, I'll take a new pointer that is start temp. Okay. And what I will do here, I will take temp is equal to head. So this head and temp is pointing to the same node now. Now here, in spite of moving the head pointer, we take temp, okay, and move it. So here also, if I take temp, here also temp. Now, if I run it again, you see here, where is that error? Okay, this one, I'll take this one for readability. So head is 2 now. What is 2? It is not been moved. Okay, so if I write temp here, then see what is the temp. Temp will be same. It will goes to the same value. So now temp is moved, not the head. So we should be very cautious while doing this operation on the head. Head should not be moved. Okay. There are certain criteria in which we move the head, but for example, reversing a linked list and other things. But we need to take a new pointer and then move it and do some operation. So this head should not be known. So this is all about how to create a linked list and how to traverse over it. So let's see in the next video. Thanks.